Now we're going to see the first Maxwell equation in the derivative form instead of the integral form, and Poisson equation. So in the previous video we saw that the electric field is equal to the negative of the gradient of the voltage. We also know that by vectorial calculus this is a vectorial field, so the curl of a vectorial field is equal to 0, and by some theorem of vectorial calculus, when we take the surface integral of a vectorial field, in this case the electric field, dot this surface, dA, and here you can put it dA and here a vector, that means the normal vector to the surface, or you can put dA with this vectorial form, that means that we are taking the dot product of the vectorial field, the electric field, and the surface area vector. So this, that is the surface integral. You can also write the integral here, but there is no need because here we have the dA. This is equal to the volume integral. Volume integral, you can put it like this or with triple integral of the divergence of the vector field. In this case, is the electric field, dB. So these things are the same because the integral of this in the A is the same as the triple integral of this dot dB. We can put it in the first equation of Maxwell, or the Gauss equation for electricity, is that the electric flux is equal to the surface integral of the electric field dot dA. So, and this is equal to the charge inside divided by epsilon naught. But this is equal to this, so we can write it as the triple integral or the volume integral of the divergence of the electric field dot dB. So we have that the electric flux is equal to this. Now we have, could be a sphere or whatever shape we have. If we have a charge density rho, this charge density is the charge inside divided by the volume. So the charge inside would be the let's say the dq, that is the infinitesimal amount of charge that we have in a infinitesimal volume, is just the charge density times dV. If we want all the charge, we would have the integral of the charge density dV. This is all the charge that is inside. So here we can replace it by the integral of the charge density dV. And here obviously we're talking about a volume integral because we have this dV, so we can also put triple integral. And because we have that the triple integral in the dV over epsilon naught, and because we have that the triple integral in dV of this stuff, this is the same as the triple integral in dV as this, then we have that the divergence of the electric field is equal to the charge density divided by divergence. The divergence of the electric field is equal to the charge density divided by epsilon naught. And this is the same as Gauss electrical flux equation, or the Gauss law for electricity, that is the first of Maxwell equations, but this is in differential form. So this is the first of Maxwell equations in the differential form. Now for Poisson's equation, so we have this, that the electric field is equal to the negative of the gradient of the voltage, and that the divergence of the electric field is rho divided by epsilon naught. So if now we want to take, let's say, the divergence of the electric field, that is here, that we have here, we would say that this is the same as the divergence of this. This is the gradient of the voltage. Here, when we have this nabla, we can put it as just nabla squared, that is taking like the second partial derivatives. So we have that the gradient of the electric field is equal to and when we have the second partial derivatives, this that is like nabla square is also called, now all this is called the Laplacian or Laplacian operator. So the divergence of the electric field is equal to the Laplacian operator of the negative of the voltage. Or you can put it as a negative here, and so you just have the Laplacian operator applied to the voltage. And here we have this, and here we have this. So we have that here we will substitute here. So we have the negative of this is this. So the Laplacian operator on the voltage is equal to the charge density divided by epsilon naught. Then we can switch signs, and we have that the Laplacian operator on the voltage is equal to the negative of the charge density divided by epsilon naught, and so this is Poisson equation.